And the little subheading that the book gives is it says estimation with rounded and compatible numbers. And this is pretty simple, but it takes just a little thinking about it here. For example, here's a problem from the book. Estimate the product of 29 and 19. Estimate the product of 29 and 19. When the book asks you to do something like that, okay, when they ask you to estimate, they want you to change the numbers that you're multiplying or doing whatever with to easy to work with numbers. Okay, that gives you an answer that is as close as possible to what the real answer would be. Okay, so technically, I mean, you could make the case and point that really any answer you give would be fine because you can do a whole bunch of different things. But you have to use a little bit of logic and reasoning here. For example, when you see the numbers 29 and 19, okay, you don't want to round 29 to 100 and 19 to 20 or whatever. You want to pick the numbers that are easiest to work with and are still close enough to that. So when you see something like this, product meaning multiplying, you're probably going to say, well, 29 is awful close to 30. 30 is an easy number to work with, and 19 is awful close to 20, and that's an easy number to work with. And multiplying those two things are pretty easy to do. You end up with 600, so my estimate is going to be 600. Okay. And that's kind of, yeah, you can hang the zero off of it. Yes, absolutely. Okay. So your job is to figure out, you know, how to round the numbers to easy numbers that are, you know, not way off from what the answer would be, but relatively close. Another example would be this: estimate this sum. And this is good because if you go grocery shopping, unfortunately, all the prices are like dollars and cents. And if you're trying to do some shopping and wondering if you have enough money, $8.95 plus $7.23 plus $11.42 plus $6.89. Okay. By the way, when you go to the grocery store, just to make sure you have enough money, you should always just round everything up and then your life would be perfect there. Okay. But again, you're looking at these and you want to estimate them or round them to a number that will make your estimate as close as really possible. So probably estimate to the nearest dollar. You know, $8.95 is close to $9. $7.23 is close to $7. $11.42, it's kind of in the middle, but it is closer to 11 than it is to 12. And $6.89 is close to $7. So those would be the numbers you add together. And what's a quick way to add those rather than just adding 9 plus 7 plus 11 plus 7? I would do 9 and 11 is 20, and 7 and 7 is 14. So $34 would be my estimate of that. Okay. Or let's see, there's probably another example here. Here, how about this one, last one? An average cat weighs 14 pounds. Now I'm just going by what the book says here. An average porpoise, I would know this. An average porpoise weighs 103 pounds.
What's a porpoise?
That like a turtle. Estimate about how, and here's the key, kids. Anytime the book uses that word about, which it does here. About means to do this. About means we want you to make it easy to do, but get reasonably close. About how many more pounds, about how much more does a porpoise weigh than a cat? About how much more does a porpoise weigh than a cat? In which case you're going to say, well, I know it's subtracting, right, because I'm trying to find the difference. The bigger number is about 100, and the smaller number is about 10. So 100 minus 10, it's going to be about 90 pounds bigger for a porpoise. That's what it would be. And like I said, again, you can make, I mean, you could always go kind of crazy and use whatever you're estimating, but we're looking at logical estimation here, not just kind of random off the wall sort of thing there. What's that?
My cat weighs 20 pounds.
Oh, well, this is an average cat, not a monstrosity of a cat.
His cat is cat.
My cousin